Hello audience. Greetings of the day. Today we will talk on electromagnetic interference in the railway tracks. The European Railway Traffic Management System, ERTMS, process is a step of sending and receiving signal from one system to another system in the railway track. All of these processes of transmitting of information consist of the frequency generated by each system that is included in the operation. Transmission of the frequency or signal between the sending source and the receiving system could cause the electromagnetic interference to any systems located in between or around the transmission operation. Thus it is a very essential to concentrate on the source of the electromagnetic radiation that occurred in the railway in order to eliminate or avoid any interference to other communication systems. In the AC, electric traction systems is operated as single-phase system and was firstly operated at 25 kV in public grid frequencies of 50 Hz or 60 Hz. This electrification was then charged to 15 kV 16 Hz system, which was supplied by dedicated 110 kV in two-phase transmission systems. Sources of electromagnetic interference. The signal or frequency used in the ERTMS is 4.2 MHz with 1 MHz bandwidth. Signal from electronic communication equipment, radio system or electric substation could interfere within this frequency range. Interference is caused by these factors that generate electromagnetic field at different frequencies. Sources that give frequency that would interrupt other frequency range are called the noise source. Location of these sources may be inside the train itself or located somewhere outside or near the train track. The train could give electromagnetic interference, where the interference comes from its power supply near the track. System causing the interference was named as the source, while the system suffering or accepting the interference causing by the source is called as victim. A source could possibly be a victim or vice versa. Three types of source have been recognized to cause the interferences in the railway track. Electromagnetic interference could cause by the electric substation and the traction power line of the railway, vehicles and traction drive of the train and equipment that could give signal to interfere with the train frequency range. External signal could be an external source from the railway and train. Besides that, the electric substation that could interfere with the railway frequency is the rectifier substation, transformer substation and the track or traction line of the railway system. Two factors of electromagnetic interference that included in the vehicle and drive section are known as the direct current, DC, fed traction drives, alternative current, AC, fed traction drives and the radiation emission from the radio frequency interference sources within the traction. Electromagnetic interferences caused by the signaling equipment could be generated from the power and audio frequency track circuit, train wheel rail contact vibration and signaling transponder. An external signal could be a source that comes from the inside the railway track and train, for example an abnormal or unusual operation condition occurring under railway system fault. An uneven of the voltage supply to the train could also produce an uneven condition of the railway system frequency and cause unintentional electromagnetic interference. Unintentional frequency could be radiated by other communication device in the railway track such as mobile phone, radio and television, thus interfere with the operating frequency of the railway system. Electromagnetic interference in the AC and DC electric systems. There are four different types of coupling mechanisms in the alternating current traction systems that will accountable for electromagnetic interference, such as conductive, inductive, capacitive and radioactive. But the dominant mechanisms are conductive and inductive coupling. By using the correct screening and earthing method, it will control the capacitive coupling mechanism that caused by the electroinduction. However, if the electrical contact was optimized, it will reduce the electromagnetic radiation that caused by the interference. As a result, the arcing that exists in the current collecting pantographs, contacting wires of OCS, overhead contact systems, and the traction units will be minimized. The contact wires that on the OCS should be suspended and aligns accurately above the train track. The interference in the direct current in the traction systems is caused by the over high voltages and strong currents that exists between the earth and running rails or fluctuation and varying of electromagnetic fields. The general mass of earth is removed from the running rails so that it will minimize the direct current stray that possibly will cause corrosion in the line side structures such as buildings, bridges, tunnels, electricity, equipment of water and others. The removal may result in hazardous levels or unacceptable of touch voltages to the general public as a result of high rail to earth voltages. The traction current produces a large magnetic fields, which will differ with the traction load. The time-varying direct current fields might affect the cathode ray tube monitors as well as the equipment in the laboratory and sensitive metering such as hospitals, nearby universities or industry plants. Improvement to reduce electromagnetic interference in the railway track. There are several possibilities that could be considered in order to reduce or eliminate the electromagnetic interference in the railway. In order to prevent the electromagnetic interference in the railway track, one of the methods is to produce electrical and electronic equipment that is electromagnetic compatible. This means that the ability of the equipment, subsystem and other system is function without generating signal to other electrical system or accepting electromagnetic radiation from other system. Three possibilities that could be considered in order to reduce or eliminate the electromagnetic interference in the railway are by installing the thyristors controlled reactor (TCR) in the railway network, shielding and grounding. There are many sources could be identified that causes the electromagnetic interference in the railway track. These sources could produce from internally and externally to the railway system itself. The effect of the electromagnetic interference to the internal and external system has also been identified. Understanding and to identify the sources from the beginning of the railway network designation and all other equipment and devices that are related will improve the electromagnetic interference in the railway track. Thanking you.